Okay, here we go. First thing we'll talk about is proportions. And what you'll notice today as we go through these problems is they will probably look really familiar to problems that you worked on either from the book or on a worksheet or that we discussed in class. This is a review, so we're going over things we've done before. So hopefully there'll be some familiarity in every problem that we do. Here we have a waitress can clean 5 tables in 3 minutes. How long will it take her to clean 28 tables? Round your answer to the nearest tenth. So essentially we have a relationship here between tables and minutes. Here we have tables and the question is how long. So we're looking for how many minutes, and we're going to set up a proportion, which is going to be one fraction equal to another fraction. And here, only because it's the way that they were given to me in the problem, I'm going to go ahead and put tables over minutes. So 5 tables in 3 minutes. And it says how long. So it's the minutes that I don't know and 28 tables that I do. And so when you set up your proportion, just be careful to make sure that there is a logic to it. 5 tables in 3 minutes, 28 tables in how many minutes? So I have my tables on top and my minutes on the bottom. To solve this, we're going to cross multiply. 28 times 3 will equal 5 times x. And let's see, 28 times 3 is 84. So 84 is 5 times x. And then to get rid of multiplication, we are going to divide by 5 on the right. If we divide by 5 on the right, we'll divide by 5 on the left. Those will cancel. And what I'm left with then is that whatever 84 divided by 5 is, that's going to equal x. 16.8. Question said round to the nearest tenth. Well, my answer already is. So here, I'm all done. How long will it take her to clean 28 tables? It'll take 16.8 minutes. You wouldn't respond with the minutes, just the 16.8. What you can expect to see on the exam is the same structure you've seen on your quizzes, where you're going to type in an answer and there'll be instructions on how to round, and you won't include the units in your answer. Sticking with proportions, at a college, the ratio of females to males is 2 to 1. If the total enrollment is 2,400, how many students are male? We definitely had one like this in the homework, and we have to read this one carefully because the ratio I've been given is females to males, but the number I've been given is the total. And so I don't want to just set this up as my ratio with the 2,400 because 2,400 is the total. If I know the ratio of females to males is 2 to 1, then what I can do from there is I could say the ratio of females to total is 2/3. So females make up 2/3 of the student body. Since the ratio of females to males is 2 to 1, then females are 2/3 of the student body. So this 2 to 1 gives me females are 2/3 of the total. A couple ways you can go from here, but I think a proportion is great. So 2 out of every 3 students are female. So how many out of those 2,400 students are female? You'll notice what we've got here is females to total, females to total. That's how we've set up our proportion. 2 out of 3, how many out of 2,400? Just like last time, we'll cross multiply and have 3x is 2 times 2,400, that's 4,800. And then in order to get x by itself, we'll divide by 3 on both sides. On the left-hand side, those will cancel, leaving just the x. And on the right-hand side, 4,800 divided by 3 is 1,600. Be a little bit careful here. Anytime you're taking a quiz or an exam, you always want to be sure to answer the question that's being asked. Here, what I did was I read the problem. I figured out, hey, wait a minute. This is females to males. This is total. So I'm not just going to do 2 over 1 equals what over 2,400. That's no good at all. I need to think this through for a second and say, okay, females to males is 2 to 1. So females are 2 out of every 3 students. And that's what we'll use to set up a proportion. We did great. And we solved our proportion. And we get here, and boy, is there a strong urge to be like, well, I set up an equation and I solved it, so I must be finished. Be careful. Make sure you're answering the question that's being asked. What I found here was this is the number of female students. The question said, how many students are male? So I have one more step to do here. If I have 2,400 students total and 1,600 are male, then I need to subtract to find out that there are 800 students that are male. And so 800 will be the answer to our question here. Always take a second and go back and say, wait a minute, did I answer the question that was being asked? You know, I set up this equation and I solved it. Feels like I ought to be done. Take one more second and go, hang on. What did it ask me for? It asked me for male, so that better be the answer that I give. Again, I plan on going through questions pretty quickly, but that doesn't mean you can't ask questions. If you have questions as we go through these, please don't hesitate to ask them. Okay, up next, the title here is Pigs and Chickens, which actually leans back to something done at the beginning of our Math 122. And we had one about true and false questions on a game show back in the very first section we covered. A farmer looks out into the yard where he has both pigs and chickens. He counts 40 heads and 100 feet. How many pigs are there? And so what we've got here is we have 40 heads and 100 feet. We are going to set up two equations that have two variables. Our variables are going to be P for pigs and C for chickens. And we're going to need an equation about the heads. And let's see, that'll be 40 heads. Well, each one of these animals has one head. So the number of pigs plus the number of chickens is going to equal 40. And then I also will have an equation about the feet. See, a pig has 4 feet for every pig plus 2 feet for every chicken, and there are 100 feet total. If I had one equation with two variables, I couldn't solve this. But I have two variables, two equations. I'm going to be able to solve it. I do want to say before I go down this road with the algebra that if you want to do this with trial and error, you can. You could say, okay, well, what if I start out with 20 chickens and 20 pigs and see if that works? If that's the right number of feet, then you're done. Maybe you need more chickens and less pigs. Maybe you need more pigs and less chickens. And you can absolutely trial and error your way to an answer here, and there's nothing wrong with that. We'll go ahead and do it with the algebra approach. And what that's going to be is I'm going to look over here at this equation and say, you know what? That's the simpler of the two. What I'm going to do over here is I'm going to subtract C from both sides. That cancels these and gives me that P is 40 minus C. What that allows me to do is take this 40 minus C and P are equal to each other. So wherever I see a P, I can put 40 minus C in for it in the other equation. And that's what we're going to do. We're going to plug that into our other. We're going to have 4 times, instead of P, I'm going to write 40 minus C plus 2C equals 100. Now I have one equation with one variable right here, and I can solve it. We'll distribute that 4 and have, let's see, 160 minus 4C plus 2C is equal to 100. I've got like terms right here, so I can combine those. And I'll have 160, let's see, minus 4 and positive 2. That'll be minus 2C is 100. And now I've got a choice. I could just subtract 160 from both sides. So let's see, if I subtract 160 over here and subtract 160 over here, those will cancel, leaving me with negative 2C on the left and negative 60 on the right. The last thing I'll need to do is divide both sides by negative 2. When we do that on the left, we have C, and we do that on the right, we get 30. What I just found out is there are 30 chickens. Make sure we're careful. I went through a lot of work here. I set up 2 equations. I figured out what P was equal to. I plugged it into the other equation using substitution, is what that's called. And then we solved the equation and found out there are 30 chickens. But I'm going to go back and make sure I'm answering the question I was asked. This said, how many pigs are there? So I'm not done yet. Now this one, I can see if there's 30 chickens and there's 40 animals, then the number of pigs must be 10. We could use this equation if we wanted to. 40 minus 30 would give me the number of pigs, but this one, the numbers are so easy, we could kind of do it in our head. If there's 30 chickens, there must be 10 pigs. But make sure you give the answer that you were asked for. If it asked for pigs, make sure you respond with pigs. Algebraically, that's probably the most complicated thing we'll see, possibly all semester. So if the algebra there makes sense to you, then you're doing great with algebra in general. Okay, types of graphs. So we looked at 3 different types of graphs, and they all sort of serve a purpose. If we want to see the raw data from a graph, then a bar graph is our best choice. We can actually see the raw data when we make a bar graph. We can see it in the frequency that's on the y-axis. If we want to see percents or comparisons between percents, that's when a pie chart or circle graph, you could call it either one, is the best choice. And if we want to see change over time, that's when a line graph is the best choice, where we'll have our time down here along the x-axis, and we'll see things go up and down over time. If I'm going too fast or if you have questions, you let me know. Like I said, I want to go fast because I want to make sure I get through everything, and I'm not sure how long it'll take, but you know, you can tell me, hey, slow down a little bit here. You're making me burn my paper up with my pencil. So y'all keep me in check and ask questions if you're not sure of something. Yeah, you bet, Stephanie. It felt like we weren't on that page for very long. So if we want to see the raw data, we want to use a bar graph. If we want to compare percents or see what the percents or the relationships are, we want a pie chart or a circle graph. And if we want to look at change over time, we're going to use a line graph for that. No problem at all. And everybody else, do what Stephanie did there and let me know if you need me to slow down or go back, or if you just have a question about the content, that's okay too. My hope is seeing it again, it's like, okay, I remember this, I'm comfortable, this is great. But if not, please don't hesitate to ask questions. Okay, on the topic of pie charts, if we were gonna make a pie chart, students were surveyed to see how they get to campus, and the results came back that 120 go in a car, 80 ride a bike, 70 ride the bus, and 30 walk. If you were going to make a pie chart, how many degrees would you give for car? And this is rooted in the idea that if we were making a pie chart, we have 360 degrees that we need to distribute among those categories. And so essentially what we want to find out here is how many of those 360 degrees are we going to give to the topic of car? Really important number for us here is the total number of students involved. And so we need to add up all the people that were surveyed. And we have 120 plus 80 plus 70 plus 30, that's 300. And now really this becomes a proportion question. When we want to figure out how many degrees to give to a certain category, we're going to use a proportion. We're going to say, okay, how many degrees for car? Well, 120 out of 300 rode in a car. So 120 out of the 300 people rode in a car. So the question then is, how many out of the 360 degrees do I want to give to that category? And our idea here is this: how many people out of the total, how many degrees out of the total? So that's the logic we're using to set up our proportion here. Good thing we know how to do proportions, because that's how we're going to answer this question. We'll cross multiply. 300 times x is whatever 120 times 360 is, 43,200. And then in order to get x by itself, we're going to divide by 300 on the left, divide by 300 on the right. Those cancel. And I'll have x is equal to 43,200 divided by 300, which is 144. So how many degrees will you give to car? 144 degrees. We could do the same thing with bike, bus, and walk. The only thing that would change is the number that goes here, because it's how many did that compared to the total. How many degrees should it get out of the total number of degrees? Misleading graphs, a way to sort of get somebody to see your point of view, if you will. If you wanted to make the changes that are shown in a graph look more dramatic, and those are the key words here, what would you do? Oh, sure thing, Riley. There you go. I'll leave it up there. No problem. This is one of those days where, I mentioned at the very beginning of the semester that I hadn't done 123 as a web remote class before. And so some days I may finish early, some days I may run out of time, and it's something that's always on my mind. And especially with the exam review, I want to make sure I get through everything. And so I was worried going in if I was going to go too fast. And so you guys keep me in check with that. Oh, that's a fair question, Edison. While we're here, the exam is going to be like a double quiz. So your quizzes have been 10 questions and 45 minutes. The exam is going to be 20 questions and 90 minutes. So as far as the pace goes, it's going to be very similar to what you've had on quizzes. Exactly the same. 10 questions in 45, you'll have 20 questions in 90. So basically a double quiz. That's an excellent question. Okay. If I want to make the changes look more dramatic, what do we do? And you probably remember, if I want to look more dramatic, then I want to zoom in. I'm going to truncate that axis. Instead of going from 0 to 100, if we want the change to look more dramatic, we can zoom in and just go from 90 to 100. And when I do that, by truncating the axis, by changing what's going on in my y-axis, if I want it to look more dramatic, then I am going to zoom in or truncate. What that means is, if we wanted it to look less dramatic, if I wanted it to look like, oh, there's hardly any change at all, in that case, that's when we want to zoom out. After we got done with sort of some proportions and problem solving, then we moved into our measures of central tendency, our mean, median, mode, and range. Frequency tables are a great way to investigate mean, median, mode, and range. So we'll go ahead and take a look at those. And here we're just going to look at mean, median, and mode. Here we have a table where it's age of cars that are in a parking lot. And we can see that the age of the cars are our data points, and we have our frequency column over here on the right. That's how many are there. Remember how to read a frequency table. There are 5 cars that are 1 year old. There are 9 cars that are 2 years old. There are 13 cars that are 3 years old, and so on. So that's what we can see there in our parking lot. Remember, our data points on the left and our frequency on the right. And if we want the mean, we need to add them up and divide by how many there are. Be very careful here. When we find the mean, we're going to add them up and divide by how many there are. There aren't just 6 data points. Instead, the total number of data points is what we get when we add up the frequencies. So the number of data points we have here is 5 plus 9 plus 13 plus 14 plus 6 plus 2. That's 49. So we have 49 data points. When we go to find the mean, we can use X bar as our abbreviation for the mean. And let's see. I have 5 ones in this data set. I don't want to do 5 plus 5 plus 5 plus 5 plus, or excuse me, 1 plus 1 plus 1 plus 1 plus 1. Instead, I'm just going to do, well, there are 5 cars that are 1 year old. And there are 9 cars that are 2 years old. There are 13 cars that are 3 years old. There are 14 cars that are 4 years old. 6 cars that are 5 years old. Run out of space. And let's see, 2 cars that are 6 years old. Squeeze it in there. And we'll add all those up and divide by 49 because we have 49 data points. X with a bar over it's just our abbreviation for mean. And let's see, 5 times 1 is 5. 9 times 2 is 18. 13 times 3. 14 times 4. 56. 6 times 5 is 30. And 2 times 6 is 12. All added up and divided by 49. Order of operations matters, and you might think, I thought you divide before you add, and that would be a fair thing to bring up, because please excuse my dear Aunt Sally, we would divide before we add, except whenever we have a division bar like that, we do everything on top, do everything on the bottom, and divide last. So now we need to add all those up that are on top. And so I'll add all those up that are on the top, and let's see, that's 5 plus 18 plus 39 plus 56 plus 30 plus 12. That's 160 divided by 49. This didn't tell us where to round. I'm going to go ahead and say let's round to the nearest hundredth. We'll do that division. 160 divided by 49 and get 3.2653. I lost my pen. Sorry about that. I'll be right back. There, 3.2653, and that keeps going. And we were told to round to the nearest hundredth. And so we'll find the hundredths place, which is 2 past the decimal. We'll look 1 space to the right. Since that's 5 or larger, we'll round this up. And our mean then is going to be 3.27. The mean age of the cars in that parking lot is 3.27 years. Mode's really easy to find, especially when we have a frequency table. For a mode, we just look at the one that occurs the most. And I look over here in my frequency column and I see, well, there's 5 of these, 9 of these, 13 of these, 14 of these. Hey, 14, that's the biggest frequency. And so the data point that occurs the most is 4. And so the mode is 4. That's the one that occurs the most because it has the highest frequency. Finally, and probably the most complicated of the measures of central tendency on a frequency table is the median. The median is going to be the number in the middle. We have 49 data points. It's an odd number, which means there will be one right in the middle to be my median. And there will be 48 other data points. Half of those, 24, will be lower than the median. Half will be higher than the median. So in my data set, I have 24 data points below the median, there's a median, and then 24 points higher than the median. Which means if I start counting from the lowest towards the highest, Data points 1 through 24 will be down here, and it is the 25th data point that I get to. That's going to be my median. So that's what I'm looking for, is the 25th as I count from lowest to highest. There are 5 ones in here, so that's data points 1, 2, 3, 4, and 5. And then I'm going to use my fingers here. The next 9 are data points 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's 6 through 14. I'm looking for the 25th. I haven't made it there yet. The 15th data point is going to be one of those 3s, and now I'll count on my fingers, 13 data points from there. 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Fifth data points 15 through 27 are in there, and hey, I was looking for the 25th data point. I just found it. The 25th data point is a 3. And so the median of this data set, if I were to list them all out, is 3. Finding the median from a frequency table can be a little challenging. Let me know if you have any questions before I go forward. Awesome. Very good. Some problem solving we did involving the mean. And really what these are about is the formula for the mean, that if we want to find the mean, what we do is we find the sum of the data points and we divide that by the number of data points. Add them up and divide by how many there are. And it seems simple enough on its face, but then we run into some problems where we might not even recognize that it's a mean type of problem at first, and then we have to figure out how to solve it. Here's one of those. A student has taken 6 exams and has a mean of 78.5. One exam remains. What score is needed for an overall mean of 80? The way we approach these is we look at what the student has done so far. And the key here is this formula for the mean has 3 parts. If we know any 2 of those 3 parts, we can find the third one. And that's what's going on here. So far, this student has a mean of 78.5. So we know what the mean is. That mean of 78.5. And we know they've taken 6 exams, so we know what the number is. What we don't know is how many points they've earned so far. We could call it the sum if you want to. That's the sum of their exam scores so far. If we had all their exams added up, divide by 6, it must be 78.5 because that's their mean. We don't know any individual exam score. We just know if we add them all up, divide by 6, we get 78.5. What that allows us to do then is if I multiply by 6 on the right and multiply by 6 on the left, these cancel. And so the sum of their exam scores so far must be 6 times 78.5. Oops. 6 times 78.5, which is 471. So what this tells me is so far this student has earned 471 points. What they would like to do, what they need, is they would like to have an overall mean of 80 after they take one more exam. So what they need, what they're hoping for, is to have a mean of 80. We don't know how many points that'll take. And here's the key part of this problem, the place where you might make a mistake if you make one, is they've taken 6 exams so far, there's 1 more to go. So after that exam, now we're talking about a mean involving 7 exam scores. So what they want is, after they take this next exam, that their point total divided by 7 will be 80. They want to have a mean of 80. Similar to what we did on the other side, we'll multiply by 7 on the right, multiply by 7 on the left. And so 560 is the sum that they need. Okay, so they're trying to get to 560. Right now they have 471. They need to bridge that gap from 471 to 560. So we'll take 460, we'll subtract 471 and find out that they need 89 points. on that last exam. In order to have an overall mean of 80, they're going to need an 89 on that last exam. And yes, you're exactly right, Genesis. That 7 is a key part of this problem, and you nailed it. Yep. Okay. Some more problem solving with the mean. This one's a little more abstract than the last one. The mean of a set of 5 numbers is 6. If one of the numbers is removed, the new mean is now 7. What number was removed? Here again, on first glance, this might not feel like a question that involves the formula for the mean, but it is about the mean. You'll notice the question about this student, the thing that was emphasized in the problem for us was they have a mean, they're looking for a mean. That's what can point us towards using this formula. And here in this one, we know what the mean is now, we know what the mean is later, and that can point us towards this formula. So there's definitely a clue in the question on how we're going to solve it, for sure. Okay, so, and similar to the last one, right now, I have a mean of a set of 5 numbers is 6. So I know what the mean is. I don't know what the sum is, but I know there are 5 numbers. And so I can find that sum. Anytime I know 2 of the 3 pieces, I can find the third piece. And here, the mean of a set of 5 numbers is 6. I don't know what any of the numbers are, but I know that if I multiply by 5 on the right, multiply by 5 on the left, I know that the sum of those numbers is 30. I don't know what any of the numbers are. I just know if I add them all up, I get 30. And then if one is removed, so I called it now over here. I don't know. We could say, after you remove one, whatever you want to sort of call it. After we remove one over here on the right, we're going to do that. And after I remove one, the mean is now 7. So now I know my mean is 7. And previously I had 5 numbers. I've taken one away. So now instead of 5 numbers, I only have 4. And just like we've seen before, when we're using this formula, I'm going to multiply both sides by that 4. These will cancel, and I'll find out that 28 is my new sum. So when I started out, I had a sum of 30. Now I have a sum of 28. So the number that must have been removed to take me from 30 down to 28 must have been a 2. Key here is recognizing that we're talking about the mean in the problem, and so the formula for the mean is going to be our catalyst to solving it. Okay. Some more problem solving with the mean. This one's a little bit different. We're not necessarily going to use the formula for the mean in the same way here. You could, but I think there's a better way to handle a problem like this, and that's what we'll look at. A morning section of a class consists of 18 students, and their mean score was 88. An afternoon section took the same exam, and those 24 students earned a mean score of 81. What was the overall mean score for this exam? What you don't want to do here is say, well, there was a mean of 88 and then a mean of 81, so I'll just add those up and divide by 2. That would work if the classes had the same number of students, but they don't. In some ways, this is a weighted average, which we're also going to look at later on. I think the best way to handle this is by creating a frequency table. And basically what we've got is our score over here, and we've got our frequency over here. And there were, let's see, the mean score was 88, and there were 18 students who had that score. And we had a mean score of 81, and there were 24 students who had that score. And so essentially what we've done here is we've created a data set that has 18 88s in it and 24 81s in it. And now all we're doing is looking for the mean of this frequency table. Important part of that is the total number of data points, which we get from adding these two frequencies, that 18 plus 24. So we have a total of 42 data points. And now we'll go find the mean for this. So I have 18 of these 88s. So when I want the mean, we'll do, let's see, I have 18 times 88 plus 24 times 81. And the whole thing is going to get divided by 42 because that's how many data points there are. From here, we're probably really comfortable finishing it up. And 18 times 88 is 1,584 plus 24 times 81 is 1,944. That'll all get divided by 42. So let's see, we'll add those up and have 3,528 divided by 42. And it looks like our mean score was 84. So our overall mean was 84. It's important to recognize that we have 42 data points here, not 2. And I think a frequency table is a great way to handle a problem like this because you're probably very comfortable finding the mean from a frequency table. So when we take this and we put it in this format, now it becomes something that's really familiar and easy to handle. That's my expectation. You can let me know if I'm incorrect on that. Okay. Now we get into the more recent content. You know, we're working through things that were on quiz 3 and a little more recent. So in some ways it'll feel like, wow, we just learned that, which is good, but this was the most challenging section. So I want to make sure that we're patient and careful as we go through it. If we want to find the 5-number summary for a data set, then we're looking for 5 things. We're looking for the lowest, we're looking for the lower quartile, we're looking for the median, we're looking for the upper quartile, and we're looking for the highest. This data set has 21 data points. They're already arranged from least to greatest. If you're given a data set and asked to find the 5-number summary, make sure the first thing you do is you arrange them from least to greatest. Okay, find our 5-number summary here. Well, the lowest and highest, those come pretty easy. The lowest is 65, the highest is 96. First thing we're going to find of the remaining 3 is the median. If we have 21 data points, that's an odd number. So there will be 1 right in the middle, and there will be 20 other data points. 10 will be lower than the median, 10 will be higher than the median. So our data set of 21 data points will look like this. 10 that are lower than the median, 10 that are higher than the median, and a median right smack dab in the middle. And we'll section it off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's my lower half of my data set. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's the upper half of the data set. It's important to note that this median that's right here in the middle, it's not in the upper half, it's not in the lower half. It's just the median all by itself. And the median of our data set here is that 79. I also need to find the lower quartile and the upper quartile. The lower quartile is the median of the lower half of my data set. Again, median's not in the lower half, so that's not part of it. It's just those 10 numbers that are the lower half of the data set. And so what I want to do is find the median of that. Well, in here I have 10 data points. That's an even number. So I don't have 1 right in the middle. I'll have 5 numbers lower than the median of the lower half. I'll have 5 numbers higher than the median of the upper half. And so we'll section those off. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. When I have an even number and I'm looking for the median, the approach is to find the two numbers that are closest to the middle, and it's the mean of those that will be the median of that piece of my data set here. 74 and 74. Some of you are very comfortable saying, well, halfway between 74 and 74 must be 74. You'd be right. Others might want to write it down, and that's fine. 74 plus 74 over 2. That's 148 over 2. That's 74. And so we just found that the lower quartile, the median of the lower half, is 74. We're going to use the exact same process to find the upper quartile. The upper quartile is the median of the upper half. Again, that's these 10 data points right here. The median is not a part of the upper half. It's not a part of the lower half. So it's only those 10 data points. We'll go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And so our upper quartile is going to be the median of the upper half, which is going to be the mean of those two numbers, 86 and 89. Some of you may be very comfortable saying, well, okay, that's halfway between those is 87.5. Excellent. That's fine. If not, it's perfectly fine to say, well, I want the mean of those. That's 86 plus 89 over 2. And that's 87.5. And so our upper quartile of this data set, the median of the upper half, it is 87.5. It's perfectly fine for the median not to be a number that's in the data set, for the quartiles to be numbers that aren't in the data set. But that's finding a 5-number summary. Okay. Weighted averages. We looked at a couple of different ways to examine weighted averages. One of those was calculating a grade for a student where they might have homeworks, quizzes, and exams that all count for a different percentage. And so here in Claudia's math class, homework is 20%, quizzes are 30%, exams are 50%. If her scores are as follows, what's her overall percentage in the class? The first thing we do here is find the percentage for each of these categories. So we're going to find what is her homework average, what is her quiz average, what is her exam average. And when we say that, we're talking about the mean. So our homework average here is going to be 100 plus 80 plus 0 plus 85. We'll add those up and have 265. Really important to note that 0 counts. So when we go to find the homework average, the mean of those homework scores, we're going to divide by 4, not by 3, because that 0 counts. So we'll divide by 4 and have 66.25. For the quizzes, we're going to do the same thing, and we'll have 90 plus 72 plus 90 is 252. And that'll be divided by 3 because there were 3 scores. That's 84. And the exams, there was only 1. So we already have the average. It's just the 85 that's sitting there. Now the weighted average part comes into play. Homework is 20% of the grade. Quizzes are 30% and exams are 50. And here's how we build that in. What we're going to do is we're going to take that homework average of 66.25 and we're going to multiply it by 20%. And rewriting 20% as a decimal, that's going to be 0.20. So 0.20 plus. Okay, that 84 that was her quiz average, that counts for 30% of her grade. Writing that as a decimal is 0.30. And then finally that 85 that was the exam average multiplied by 50%, 0.50. All we need to do is simplify this and we'll have her overall percentage in the class. And so 66.25 times 0.2 is 13.25. 84 times 0.3 is 25.2. And then finally, 85 times 0.5 is 42.5. And then we'll add those together and end up with an overall percentage of 80.95. And that's how we make a weighted average. And when you're teaching, if you want to modify how much stuff is worth, all you've got to do is change these percentages right here, and then that gets baked into this equation when you go to calculate the overall grade for a student. Another type of weighted average would be like finding a grade point average. A key thing about grade point averages to remember is that grade point average is equal to grade points divided by credits. And so it's important for us to figure out how many grade points did a student earn, how many credits were they taking. Those are going to be key parts of this. To figure out how many grade points they earned, we need to be aware of the fact that an A is worth 4, a B is worth 3, a C is worth 2, and those are grade points per credit. Just like it was on the quiz, you'll be given a table of the values of different grades. For example, I wrote down A, B, and C over here. We can see there's an A and a C. There's a B plus in there. So we're going to need to know that a B plus is worth 3.3 grade points per credit when we go to solve this. And so let's do that. Let's figure out how many grade points this student earned. All right, well, they took a 3-credit class and got an A. That's 4 points per credit. And so 3 credits, 4 points per credit, we're going to multiply those, and that class was worth 12 grade points. And then in the math class, it was a 5-credit class. They earned a B plus, which is 3.3 points per credit. So we'll multiply those. And 5 times 3.3 is 16.5 grade points for that math class. And then finally, they were also taking this 1-credit art class. They got a C in it. That's 2 grade points. We'll multiply those. 1 times 2 is 2 grade points for that art class. And we'll add those together. The total number of grade points earned is 12 plus 16.5 plus 2 is 30.5. In order to find GPA, we also need to know the total number of credits. So 3 plus 5 is 8 plus 1 is 9. And so the grade point average for this student is 30.5 grade points divided by 9 credits. It is 3.3888888. That keeps repeating. In this problem, we were told to round to the nearest hundredth. So we'll find the hundredths place. We'll look one space to the right. Since that's 5 or bigger, we'll round up to 3.39. Beautiful example of a weighted average. What's happening here is this 5-credit class counts a heck of a lot more than the 1-credit class does. And practical, because it's exactly how your grade point average gets calculated. This problem at first glance reads a little challenging, but it's very much like something else we've already done. Over the course of her first 3 semesters at college, Amy had taken 35 credits and earned a GPA of 2.90. She's taking 15 credits this semester. In order to bring her overall GPA up to 3.0, what GPA will she need this semester? On the surface, this doesn't seem exactly like the student who's taken 6 exams and has 1 more to go, but it's almost identical. The difference here is the formula, if you want to call it that we're using is the idea that GPA is grade points divided by credits. And if you squint a little bit and look at this, you can kind of see mean equals the sum over the number, because that's kind of what's going on here, and that's how we're going to handle this problem. So far, Amy has taken 35 credits and has a GPA of 2.90. So she has this 2.90. We don't know how many grade points she has, but we know she's taken 35 credits. Since we know she has a 2.90 and she's taken 35 credits, we can multiply to figure out how many grade points she's earned so far. Those will cancel, and what we find out is 35 times 2.9, 101.5 is the number of grade points she's earned so far. She has one more semester to go. What she needs is she would like to finish with an overall GPA of 3.0. So she wants a 3.0 over here. We don't know how many grade points that's going to take, but she's taking 15 credits this semester, and this is where you have to be careful. There's a little bit of a pull to want to throw that 15 down here, but don't do that, because remember, this is overall. She's taken 35 so far. She's taking 15 more, so overall, she's going to have 50 credits. It's just like when we add in that last exam. We have to tack it on to what's already been done. Okay, now we can figure out how many grade points she's going to need to bridge the gap. We'll multiply by 50 on both sides. Those will cancel. And 50 times 3.0, that's 150 grade points. So right now, she has 101.5 grade points. She's going to need 150. So we can subtract to figure out how many she's going to need. Let's see, minus 101.5 is 48.5. If the question said how many grade points does she need to earn, we'd be done, but it didn't. This says, what GPA will she need this semester? Now what we can see is she's going to need to earn 48.5 grade points, and she's taking 15 credits. So again, we lean back into this formula. The GPA that she's going to need is going to be that 48.5 divided by the 15 credits, 3.23. We were told to round to the nearest hundredth. Well, we haven't done much rounding, so I'm going to do it. So that repeats. We were told to round to the nearest hundredth. We'll find the hundreds place. We'll look one space to the right. Since that number is 4 or lower, we're going to round this down to 3.23. And that's the grade point average she's going to need this semester to bridge that gap and pull her up to a 3.0. Okay. Sounds like we're doing all right. That's great. Okay. The most complicated algebra was probably back when we did the pigs and chickens type of problem. Here is probably our most complicated formula, the formula for standard deviation. It looks more intimidating than it really is. I hope you feel that way after working on some. And remember, our data points here are x sub 1, x sub 2, x sub 3. N is the total number of data points, which is going to be 3. And x with the bar over it, that's our mean. So we're going to need the mean, so we'll find that. So our mean here is going to be, let's see, that's 19 plus 28 plus 31 over 3. Oops. 19 plus 28 plus 31. There we go. 78 over 3, which is 26. So our mean's 26. Now we have everything we need to plug in to find our standard deviation. Standard deviation, we can use the lowercase sigma as an abbreviation for that. the square root of, okay, data point minus the mean. So that is 19 minus the mean squared plus data point minus the mean. So 28 minus the mean squared, and data point minus the mean, 31 minus the mean squared, all over 3. We've got everything plugged in. Now we just need to simplify. And when we do that, we'll have our standard deviation is the square root of, say, 19 minus 26. That'll be -7. 28 minus 26 is 2. 31 minus 26 is 5. Now we'll do our squaring and have, let's see, -7 times -7, that's 49. 2 squared is 4. 5 squared is 25. And we just kind of keep moving along here. It cleans up pretty nicely. Standard deviation will be, let's see, 49 plus 4 plus 25. That's 78 over 3. Which is 26. And then the last thing I need to do, please don't forget to take the square root of that 26. And we get that the standard deviation is 5.0990. And that keeps going. We're told how to round here. Well, I don't know, let's round to the nearest 10th, just because we haven't done that yet today. You could be asked for 10th or 100th, but we haven't done the 10th. 10th place is right here. We'll look one space to the right. That's 5 or bigger, so we'll round up to 5.1. Complicated looking formula. Once you get everything plugged into the right spots, just be careful and patient as you go through the calculation. After we talk standard deviation, we talk normal curve. This is something that you'll either want to have memorized or have on your one page of notes, is this picture here. This is how we cut up what's under the normal curve in order to answer questions. This symbol here, lowercase Greek letter mu, is our mean. And so what we've done is we've got the mean here in the middle, and we've chopped this up at 1, 2, and 3 standard deviations above, 1, 2, and 3 standard deviations below the mean. Whenever we have normally distributed data, we can chop up the regions under the normal curve to see how much data is in each piece. Type of questions we'll see are like these. A standardized test had a mean of 400 and a standard deviation of 30. First thing I'll do when I see that is I'm going to sketch myself a normal curve with a mean of 400 and a standard deviation of 30. And so I'll have 30 and then 30 more and then 30 more. And on the back end, standard deviation is 30, so this goes down by 30, down by 30 again, down by 30 again. And so we've sectioned off the area under our normal curve. Now, to make it easier to answer these questions, I'm going to go ahead and put that here and put my labels here, where I have a mean of 400 and a standard deviation of 30. Now we'll answer questions. First question says, what percent scored above 430? So I'll go back and I'll look at my curve that I have labeled, and I see that I have 430 right here, one standard deviation above the mean. What percent scored above 430? That's these right here all added together. And so that's 13.5 plus 2.5, 13.5 plus 2.35 plus 0.15, 16% is over there. And so what percent scored above 430? 16% did. The next question says, What percent scored below 460? So we go back to our normal curve, and this time it says, what percent scored below 460? So I have to identify where 460 is, and I want everybody below 460. So I'm going to add up all of those together. 0.15 plus 2.35 plus 13.5 plus 34 plus 34 plus 13.5, and I get 97.5. So what percent scored below 460? 97.5%. And then the last question we have here, what percent scored between 340 and 430? We'll go back to our normal curve and we'll say, let's see, what was it? 340 and 430. So 340 is here, 430 is here, and so I need everything that's between those two. So I'm going to add up those three regions. 13.5 plus 34 is 81.5% is in between those two. So what percent of the students scored between those? 81.5%. Using the normal curve. So this is a question where instead of using the normal curve to answer a question that is what percent did this, what percent did that, this one is more along the lines of who did better. Jack scored 82 on a test that had a mean of 60 and a standard deviation of 15. Jill scored, 78 on a test that had a mean of 60 and a standard deviation of 9. Who scored better? What we're going to do is we are going to draw a normal curve for Jack. And then we're going to draw a normal curve for Jill, and we'll see who scored better. Jack's test had a mean of 60 and a standard deviation of 15. So let's see, that would be 75, 90, 105. We could draw the back end of this over here, but we don't really need to because we can see that Jack's score was 82. So he's on the right side of the mean. So his 82 is in here somewhere. In between 1 and 2 standard deviations above the mean, that's where Jack landed. Now we're going to draw one for Jill. And her mean on the test she took was 60, but the standard deviation on her test was 9. So we've got 69, 78, 87. And we can see that Jill's score was 78. So it landed right here exactly. She is 2 standard deviations above the mean. Jack, he did well, but he's, we can't tell exactly, but he's about 1.5 standard deviations above the mean. Well, Jill's score was 2 standard deviations above the mean. Jack's was 1.5, so Jill did better. Okay. There's one more page that I do want to discuss with you, but content-wise, we've reached the end of it. I didn't need to go as fast as I went at the beginning, so I kind of apologize for that. I think I slowed the pace pretty good there after Stephanie and Riley kind of pulled the reins back a little. I wanted to leave a little bit of time at the end for you to ask questions, which we have. And there's one other page I do want to talk about, and it's this. If you've had me as an instructor before, you've seen this before, and you'll probably see it 2 more times this semester. An exam can be a stressful situation. It's a little different than a quiz. You only get 1 attempt. It feels like a bigger deal because you're either at a testing center or with a proctor from ProctorU. And so there's a whole different set of circumstances surrounding an exam. What I want you to do as you go into this exam is I want you to be realistic and positive. Do not be a perfectionist and do not be negative. I want you to go into this confident, realistic, and positive. And here's what I mean when I say those things. The perfectionist says, There's an impossible number of things for me to learn for this test. Well, I can assure you that's not true. In one class session, we just did a review that goes over the main concepts. So that's out the window. Also, that's true about that, in contrast, is I don't need to know every question to pass. And that's true. You don't. You don't need to know every question to pass. You don't even need to know every question to get a really good score. So please don't be a perfectionist here. Be realistic. It's okay if you get something wrong. Do I want everybody to get every question right? You bet I do. But you don't have to. Don't put that kind of pressure on yourself. My knowledge of some certain topic is shaky. Maybe that's true. Maybe there's something we talked about today that you're kind of like, I don't know. I'm having a tough time with that. Okay, well, if you start studying now, you can learn what you need to know. You've got today, tomorrow, Thursday. You can ask questions of me either in the last couple of minutes we'll have left or by email between now and when your appointment is. So don't feel like it'd be impossible for you to learn something between now and the exam, because that's not true. In addition to being realistic, I want you to be positive. The negative person would say, I always do poorly on tests. Always is a big word. I'm guessing somewhere along the line, probably in a quiz in this class, you did pretty well. So throw that out. Don't think about that. And okay, maybe you have struggled a little, but going through this the second time, it's like, oh, now I totally get it. And I've studied, I'm prepared, I'm ready for this thing. Probably the one that really focuses in on the most for me is, if I don't pass this test, I'm a failure. Please never, ever think that. This is one test in one math class in one semester of your whole college career, which is a piece of your whole life. You are not a failure, even if you don't do well on this test. There's a lot more to you than this exam. The contrast to that is, even if you don't pass, I can bounce back. That's true. This is one test. We're in, week 5 now? We're only a third of the way through the semester. 2/3 of the semester is still ahead of us. There are going to be lots of opportunities for you to improve your overall grade in the class and to learn things that maybe gave you trouble at this point of the semester, but you had a chance to pick them up somewhere in the next 10 weeks. And then this test is going to have a trick question. Well, I'm definitely not going to try to trick you on purpose. It's possible that you do a really long equation, figure out the number of females, and then answer the number of females when the question said how many males are there. I don't think that's a trick question. You do want to make sure you answer the question that's being asked. I will not try to trick you on purpose, I promise. My favorite thing on this whole page is this one down here at the bottom right. This test is designed to let me show what I know. Maybe you struggled during a class meeting with the topic, or when you were doing problems from the book, or on a quiz. And you're like, dang it, I know how to do this. Why can't I get these questions right? Well, you know what? Now you have a chance to prove it. It's a chance for you to say, you know what? Maybe I did struggle before, but I know how to do it now, and I'm going to prove it. I want you to go into the exam well prepared, confident, and relaxed. You've done all the studying you can do.